Hello everybody, I'm Errichto, sorry for being late. So I will start in a moment, and today we will be solving a problem where we are supposed to write a game bot for two-player game, Christmas Rush, that is on codingame.com. Don't worry if you have no experience with problems like this, because we'll start from zero, from just learning the statement, and I will show you how I would approach the problem. I hope you hear me well. Let's see. Let's see if I'm visible. I think I am. So we'll wait like 1 more minute or 2 minutes for other people to catch up to open the stream, and we will move on. So as I said, I haven't yet read the statement, so I know nothing except for this picture. So I guess, and it was an animation, so I guess that we should move along the grid that is changing all the time. Yeah, you can watch me both on YouTube and on Twitch. I think links you can find in the description if you're watching me right now. The disadvantage of Twitch is that it doesn't allow you to adjust the resolution. So if you want to watch me in full HD, in 1080, then Twitch is okay, and if not, then just go to YouTube. Twitch quality is better than YouTube. Well, on YouTube you can adjust any quality up to 1080, but also if your internet is worse, you can downgrade. Category programming, maybe it's a good it's a good suggestion. Thanks. We are in science and technology. I think that from like 2 weeks ago, the category programming doesn't exist. So science and technology covers it on Twitch. So let me know if in chat if anything is not clear. Also, I guess at least for now I can keep this chat in Codingame open. Also, you will not see chat anyway because my face covers it. So let me close it. And yeah, so a game like this is usually played between two players, and they move alternately in turns. And what we're supposed to do, we're supposed to implement some program. Here, the default one is written in C++. It's a program that is provided by organizers. And basically we read what happens, maybe what happened in the previous turn, or what is the state of map, and we print our comment. For example, what we print here? We print here cout push 3 right, what likely means that we move something to the right from some position. And then everything is the while true loop, infinite loop that just repeats turn after turn. So the server, the system, plays two programs against each other, and we should try to win the game. Also, Codingame has some leaks. Like right now, by default, I'm in Wood 2 league, like in some LOL or Dota games, or like any game online. And later, if we have some good score, we advance to the next league, and maybe I think also the problem will become more complicated. Some more possibilities will be. There will be some more possibilities, more possible moves. So yeah, I will implement in C++, and as I said, feel free to comment anything. So let's move to the problem. The goal is to make your way to the items on the board and be the first to complete your quest. Okay, so we move along the grid with, I guess, some single hero, and we should collect some items. 2 players, board, square board size 7x7, so 49 cells or tiles. 0, 0 is top left corner, okay. Each player has 1 tile placed outside the board, which they can use to push a row or come on the board. So if possible, let's see it on the visualization. Codingame always has some nice visualization, visualization, and it allows you to both understand the statement quicker and later to test your code to see how it goes against some opponent. So yeah, we saw here some extra cell that pushed the whole row. And what happens? They can use that tile to push a row or column on the board, trying to make a path toward the quest items. When a user pushes a tile into the board, then the tile gets pushed will become the new player's tile. Okay, so if I want to move one row by one to the right, then I just push my extra tile here to the right, and the last tile will become my new tile that I can push in some new place. So I guess we'll need some like BFS or DFS, some search function in graph just to check if we can access, if we can get to some item that we want to get. And if it's not possible, maybe we'll try every possibility to to push some row or column by one. And later, we'll try maybe more advanced stuff, like checking what your opponent will do, or checking what I can achieve with two moves. Maybe I can move a row by one and then a column by one. But for sure, we'll start with something simple, because it's much easier to write a simple solution and to do small improvements instead of just jumping to 1000 line code, because then mistakes are harder to find. The board contains square tiles with paths on them. A path can lead to one of 4 directions. Yeah, we see it here. Some tiles have an item on them. Each quest corresponds to an item on the board. Quests are the same for both players, but each item is unique in the deck. Okay, I thought at the beginning that we want to get to some items, but actually I think there's a competition between you and your opponent, whoever gets first. To complete a quest, a player must move to the tile containing the corresponding item. The quest must be revealed to be able to complete it. So at every moment, we want to get to one item, one particular goal tile. For this league, each player has one quest to complete. And this is what I mentioned, that there are leagues. We start in the most basic one where it will be easy to advance and easy to write some algo that beats your opponents. And later, something more complicated will be described in the statement. There will be some changes to the statement. Each game turn alternates between a push turn and a move. So we change one row or column and then move. So we move column, we push row or column. If both players push the same row or column, no matter the direction, nothing happens. Okay, so I thought that we move first my turn, then opponent, but here apparently we move at the same time. And if we decide to push the same row or column, then it cancels. If push commands intersect, the row is pushed first, followed by the column. So if I push a row and opponent pushes column, then first it's row, so it's some implementation detail. If a player is on a tile which gets pushed out of the map, the player is wrapped on the other end of the line. Okay, so we can teleport. Maybe it will be useful eventually. To allow a player to move between two adjacent tiles, the tiles' respective paths must connect to form a longer path. Okay, each player can move at most 20 steps during this turn via connected paths. Okay, I thought that every turn we would move only one step, but here on such a small grid, 20 seems like a huge number. I think we can get almost anywhere in our connected component. So for example here, let's say if I'm here, I can get in one turn to any of these cells. Every push turn the player must do push, move, and do nothing. And move can obtain up to 20 directions, each direction separated by a space. And we must win in 150 turns. That is, after 150 turns, we must have more quests achieved than our opponent. There is also some time limit. Of course, we can't print anything that is invalid, but these are there must be some limits, right? Also, you can see the game's source code here. I guess it will be possible to simulate the same on our machine manually, but it isn't important for us now. So today, for sure, I will just implement here. But first, if it's possible, I will try to increase the font. Maybe someone can help me with that, if it's possible. What happens now? I guess that will work. Yeah, so the font is bigger now, and it should be better for us. So when I simulate a game, I think I will full screen this, and when I implement, I will be in this window, and also let me full screen. Yeah, so I tried Control plus, oh, Control comma. Okay, let me try it. Awesome. Font size, so let me get back to the initial size. 20, 25. Seems reasonable. Maybe I will adjust it later. Yeah, so and if you want to see me, like, if you want me to answer a comment or see your comment, then maybe let's say that we don't use this Codingame chat just because anyway messages from YouTube and Twitch will be shown on screen above my head. So I want to keep this chat closed. So yeah, let's move to implementing something. And as I said, it's best to implement something very basic. So what we do, let's see what our given implementation does. While true, so infinite loop, we read turn type. So let's see what is turn type. Input. Okay, so turn type is either push or remove. So then we read a grid. Every cell is apparently a string. Let's see what this string describes. 4-digit format. Can we see some example? I guess we must read through all of this. 7 times 7 space separated strings representing each tile on a row, starting from the top. 4-digit group, each digit corresponding to a directional path. Up, right, down, left. 1 means the tile has a path for the respective direction. 0 means the tile doesn't. Okay, so I guess if the string is, for example, this, then every next digit corresponds to one direction, up, right, down, left. So in this case, for example, we could move from this tile right, down, or left, assuming that that corresponding cell also has a proper like path, a road. So let's start doing something. I will create some constants for directions. It's kind of standard. The row of 4, 1, 0, 0. The call of 4 as well. So now the row of I, the call of I gives us vector of ith direction. Let's also adjust the directions. The order here is up, right, down, left. So let's follow this. Up is indeed -1 row if we number rows from the top. Here then direction right. So we increase column by 1. Down. So 1, 0. And finally left. So this is up, right, down, left. Let's let's create a two-dimensional array for the grid. I hope that the size 7 times 7 will hold in the following leaks, because I'm going for simplicity to use the constant 7. Or is it a bad idea? Well, maybe let's call it nicer. Let's say that it's a constant that we can maybe later change it or read from the input. So when we read the grid, we go row by row, column by column, and we read the corresponding string. And what we need, let's create a function that tells us whether we can go in some direction. Can go gets row, column, and direction. Direction is from 0 to 3. And what we want to check? Well, let's for now return whether in this cell the 4-digit string has a 1 in this place, but it's not enough. So this tells us that in our current cell we can indeed go in this direction, but maybe the next cell doesn't allow us. So what we need is also, let's create a cell R2C2 using the constants that I created earlier. And also that cell, so in R2C2, something also must be 1. But what else can be excuse me, what else can be wrong here? Well, R2C2 can be outside the grid completely. So let's create a function inside that checks if row and column are between 0 and 7. 0 and n. So here, let me write inside of R2C2, and some character must be a 1. Which character is it? Well, if we go up, then for that cell our direction is down, right? If, for example, we are in this cell as green hero here, he wants to go up. For this cell, so this is cell R2C2, we want to check if route in direction down exists. So here, instead of checking dir, we want to check the opposite, and the opposite is always, I guess, for 0 it's a 2, for 1 it's a 3. So opposite direction dir_2, I think. For 0 it's a 2, for 2 0, and 1 and 3 also pair up. So here it will be, for me it will be easier to write in inverse direction. It's shorter and I'm used to name like this. So yeah, I think this function, what we achieved so far is that we can check if we can go in some direction. 7 times 7 is fixed, okay, but I'm using 9s anyway, non-const x. I learned using const and it's very hard for me to switch. You should make your cam smaller, no problem, I will in a moment. Can you move your camera comments to the left? Okay, both camera and comments. Makes sense. Why don't you use define end instead of const int n? Because it's better to use const. Define only pasted something, so it's bad. For example, if you write defined n 2 plus 2 and then you write 2 times n, it won't be 8. And let me move everything. how to do it. Now it should be better. Also, let's remove this thing. So let me know if it's better now. Yeah, I agree that we can use defines correctly, but const is for constants. Like, it's better, it's designed for that. So also, if you have a job, then you must write in some code style, so it's better to use constants. Can you shift your camera? Is there a way to lower quality? I have some like 1080p. So I will write also in chat for in case he doesn't see me right now, for Twitch users. If you want to adjust the quality, well, someone said that. If you want to adjust the resolution, go to YouTube. So yeah, that's the disadvantage of Twitch for me. Through YouTube, and yeah, as I said, I'm not used to const exp. Why do you name functions like this? Can go instead of can go. It's easy to read. So if I am to choose between I am lazy and I am lazy, then it's easy for me that here underscores replace spaces, right? And that being said, it's just about code style. It doesn't matter much. So you can read, for example, Google code style. It's kind of nice. I'm not sure if I use it entirely. Maybe defines have some advantages, but they have disadvantages as well. Yeah. Thanks for doing. Well, thanks for watching. Yeah, let's move on. And yeah, regarding my, for example, should I use const or define? If you're interested in the discussion about this, I guess the best way is for you is to just Google define or const. There will be some experts explain why which is better. But for some reason, consts and const exp are better. And for example, define computes something every time, while constant is one constant value. Okay, can go. So what do we do here? Let's read the rest of the input. Here, I guess I need to run read grid, what I have here. Turn type, sin ignore. What does sin ignore do? Why doesn't it work? Get line call, something with white spaces, I guess. So if they use it, let's keep it. I can remove it. So we read our goals. For now, I guess we assume that the goal is common. So goal is, let's set the goal to -1, and here it's more complicated than that. Let's read the input description. So we've read the grid. Next two lines: for each player, number of player cards, player X, Y. The player's position, okay. So an important thing is usually, well, a hard thing to do is to decide whether I should use row and col, or maybe a pair. Let's use pairs. Me, he. Okay. the total number of quests. Let's say that it's a grid of size 2, and hero of 0 it will be me, and hero of 1 it will be him. Okay, so for every player, let me create a function that reads per. Read scene. We read the coordinates. What else? The number of maybe I should create a struct for a player. I'm not sure if it will be better. Player's input comes first, the opponent's comes second. Yeah, let's create a struct for player. It will be nicer, and also I guess my hero and the opponent has the same style, so let's do it this way. And now I think it's better to create row column. And what do we have here? String player tile, the player style in 4-digit format. Do we need this? I think it's redundant. I think we can read it from the grid. So number of cards. We read the number of cards, we read the coordinates, and we read this cell description, but for now I will not use it. Maybe use in the future, but I don't think how I would use it now. So I create me and opponent, and I read both. I can remove all of this. Read the items. Okay, for now let's keep it this way. Number of quests, also let's keep it this way. And now, so let's try maybe testing our function, whether we indeed know in which directions we go. And for that, here I will get a random direction, 1 of 4, and I will check if I can go in this direction. So if me can go in this direction, then I will write, I can also push, but I can move in this direction. So I will write move and direction name of view and new line. And I will remove pushing the row. So I used function can go. That should check where it should run this can go. Return can go from this row, call direction view. So my goal here was to just move randomly in the grid. Of course, you could immediately write some DFS to find the closest item, or maybe any item, but it's more complicated. Let's start with something simpler. Of course, so let's see if my code works. Okay. Player tile is what you push in the grid. Okay, thank you, Euler Shizaki. So yeah, it will be important. Struct cell intro call will be nicer. Per first second may be confusing. Maybe. Okay, so I have some compilation errors. Assert was not declared, so I didn't include everything that I would want to get. So bits std c++h includes almost everything in C++. What else? no matching function to call, player can go. I want to run the global function, so maybe I should write it like this in C++, I'm not sure. Invalid use. I don't remember how to use. Okay, quick hack. For a moment, let's do it like this. Oh no, I've put it in the wrong place. So here I want to run a global function. What else? Dir name is not created. So let's create it. Const string greet dir name. Where was it? Dir name of 4 is up. Was it uppercase or lowercase? Uppercase. Up, right, down, left. Let's see. Maybe in a moment we'll have some program that runs. And I've lost immediately. Why did I lose? Timeout, no input provided. Okay, so I print something wrong apparently. Or maybe I run forever. What can I do? I think I can. I'm not sure if I can do it. With CRR I can write to the error output. So let me check just if I get to every place. So by printing A here and C here, I will see in a moment whether I get to these places at all. It's a bit strange because here I see BCA. I guess it stopped after A. Maybe I also need to print push all the time or not. Maybe pass. Why not enum? Yeah, it can be used here. You cannot move on the first turn, only push. Can't I? Oh, because so maybe if turn type is turn of moving, then I do this. And moving turn was 0 or 1. Let's see. 0 was for push, move for 1. So turn push is 0, turn move is 1. So I will repeat that many times. Remember to do basic things first. So here the program is just move randomly to the direction that you can move, and still I'm getting some mistakes, like some errors. Okay, did I understand the suggestion correctly? If run didn't give a correct direction, your code doesn't print anything, it just skips. Okay, makes sense. But is it a bad thing? I guess so. I guess I should print a pass. Else cout pass, and also here else cout pass. Each game turn alternates between a push turn and a move turn. The first turn is always a push. Okay. Yeah, else cout pass I added, and you need to print a push comment. But I can also skip a push, right? Okay, compilation error, else, I didn't cause brackets. Of course, thank you everybody for catching some mistakes. This way it will be faster. Can't pass while expecting a push action. Okay, I can. So push 3 right. Just like they did here. Which player am I? I'm red. Can I speed it up? I can. So I read and I expect my hero to move randomly. Does he? No, I guess he does. So now let's make him move all the time. So actually here I will check all directions. So let's check every direction. If me can go in this direction, then we move. Also, let's create a function to move. Print move of dir. Just to make the main easier and to extract all the easy functions somewhere in the top. What is it? How did I name it? Print move. Print move, and it only gets direction. I could possibly also here modify player, but for now I don't need it because every turn I read everything from the input anyway. Possibly someone in the future, maybe at the bottom of my code, let me write down some ideas. Ideas that I will likely not implement myself, but you can consider it as ideas for you, or it just to show you what I think during, like, while solving this problem, what I leave for later. So right now I read every turn everything from 0, and if someone in the future it should make sense to make some plans. So make plans and remember history between turns. So also then I would modify here in this place player, and I would maybe update everything myself. So this will be some ideas. Okay, so here otherwise I want to pass. So let's me. I don't want to move twice, so here I will add a break. Here I check if I moved already. So I create a boolean flag. Here, if not moved, then I pass. So now I expect my hero to every time first write direction 0, so 0 is up, then if not possible right, and so on. So he prioritizes up, then right, down, left. Did it run indeed from 0? I'm not sure. And if yes, then maybe something is wrong, but because I don't think he all the time prioritized in this let's say order. Let's decrease speed. I think a moment before this, my player could move down, and he didn't. Let's investigate that now, while my code is quite simple. If I can go in every direction, so I check directions. I do. So let's investigate the can-go function. So this will be a new cell. And I check if in my cell I have a 1 in this place, and also that other cell is inside the grid, and the corresponding character says that, yeah, there is a row there. What about simpler functions? Row and column are inside from 0 to n minus 1. Let's check if... I hope that I number rows and columns correctly from 0 to 6. Maybe someone has a suggestion. When did this start? It started half an hour ago. Can I still follow the stream and understand? You can visit codingame.com and open the Christmas problem and read the statement yourself, and then get back here and watch me solving this problem. So we've just started, and I'm just trying to implement something basic, a program that moves a hero randomly through the grid. So now I'm just checking if it seems to work. And I think it doesn't. So here I wanted to say that my opponent moved, but actually the whole column was moved. So I want to see a moment when my opponent moves, but I don't. So it was a moment ago this happened. So let's also here for error output, let's say can't move at all. Let's run this, and this way I will, so here Codingame shows me which turn is it. Maybe my face covers this, but it doesn't matter much. Well, here we know which turn is it, and I can see below that in these logs I can scroll through, I guess. So around turn 160, I think, something bad happened. So green moves all the time, and red doesn't seem to. Am I red? I'm red. Okay. Invalid input. Move down. So I try to move down while I can't. Okay, let's get back to the statement, and maybe I don't read the input correctly, for example, and this is why I think that I can move in some direction, but I don't. Also, this is an example of quite complicated problem for starting it, where you need an hour just to have something basic working, but then it gets more fun. Then you have a working code, and then you will try some new approaches, strategies. So maybe you want to go to the nearest item. Maybe if you see that your opponent is close to the goal, then you move him. So you move his row or column and stuff like that. Okay. Move down. Let's see. I think you need to update the player XY after moving in that direction, then check if can move again. For now, I only consider moving once, and then in the next turn I will read everything from 0. But if I want to make many steps in one turn, then yes, I will have to update. Problem with inverse direction, maybe. Let's check. Inverse direction. Dirk sort to. So up with down and right with left. Seems okay. Directional path up, right, down, left. Seems okay. What about directions here? -1. Okay, do I print row first and then column? Well, do I read in this order? The player's X position, the column. So it's first column and then row. Okay, so this was a mistake. So here, column first and row second. Let's run the code again. So as you can see, I guess I caught a mistake, but it would be much harder. It would be much harder if my program would be more complicated. So does red now move all the time? He seems to increase the speed. So there were some priorities, and this is why he doesn't move in some interesting pattern. But let's go through the outputs to see if there are some errors on my side. I sometimes print can't move at all. For example, in turn 112. Maybe, okay, so in 112 right now, and it's true, indeed, right now I can't move. Okay, makes sense. So now let's make more steps in one turn. So repeat up to 20 times. So let's create vector of string moves where I will push those left, right, up, down. At the end, if what I will do here, if moves empty, then I can't move. Otherwise, I run print moves of moves. Actually, here instead of strings, let me hold directions from 0 to 3. Or do I hold here strings? Maybe strings. It will be easier to understand if I want to print it, maybe. Do I want to? Let's keep int. From int, it's easy to get to strings. Print moves. So let me modify this print moves. I see out. It's actually now vector of tiers. I print move, and for every direction I print the corresponding string. If I want to print just one move, then I will run print moves of just vector with a single element. Here let me also assert that it's not empty. It's generally good to put asserts because they can only help you catch mistakes. And yeah, in this function, if I am to print move something, then I want dirs to be non-empty. Okay, what happens here? 20 times I repeat. Check every direction, and if I can go in this direction, then moves pushback direction. And also I want to change my coordinates. Here it will be break still. Well, I will run some function go in this direction. And go in direction asserts that I can go, and it moves this way. So row plus equal delta row of dir, and call plus equal delta call of dir. Okay, I guess that's it. Maybe it's the XY coordinates that are swapped. Well, that was it. Thanks. If I see you can go up, you go down, and if you can go left, you go right. I see. I will read this later again because right now I don't understand what you're saying. I'll give you more support since I don't understand this problem. Okay, thank you, Ricky. What about inv_dir of left? I think inversion direction of left should be right? So for left it's a 3, and XOR 2, it will be 1. So right, sounds okay. You store bits in the grid in reverse order. Do I? But they gave me this direction. Let's check. But if there are no mistakes here, so here earlier they gave me some mistakes, like you can't make this move is invalid. If I don't make invalid moves here, it apparently I store everything correctly, right? Otherwise I would have errors. Is it okay to break only once here? It's okay, it just will make something different. If I break here, then I will again start this from 0. So 20 times I consider directions in some particular order, and if I find something, then I again start from trying direction 0. So actually what happens here, as you can see, is that you go up and down, for example. And if I don't break, then the next direction will be checked. But actually I want to break and do something interesting, like more randomish. I will create random order of direction, random shuffle it. And now instead of iterating dir from 0 to 3, I go in this random order. And let's try it now. So now I expect this to be just more random. Play in progress. When? Play my code. Okay. So now I want to see random behavior. And looks correct to me. Of course, now I can't move anywhere. 150 turns already. Not? Okay. Very interesting and smart algorithm, of course. You can see that it often goes, for example, as up and down for some time, but like, it's perfectly possible, like, especially if I'm in component that has a shape of L. Then yeah, this is how random moves look like. What I can do to add, well, to get what I can do to with random moves to get to more cells in the grid, because now I'm often stuck. Instead of here pushing all the time third row, let's see, do I push third row? So I guess this is what I push all the time, to the right. So let me instead int direction will be random direction, int let's say which column or which row will be my row, but if is so this is row, but if is vertical of direction, then which is me column. So here I generated a random direction, and here I want to take my coordinate in this direction, and now I want to write cout push which name direction of dir and new line. Also I need a function is vertical that says whether direction is vertical. So verticals are up and down, dir is 0 or dir is 2. horizontal, maybe I will need it later, return node is vertical. I wonder if I now hit, okay, name dir not declared. Maybe it's dir name. Yeah, it's dir name. While we wait, I will again repeat what we do today for those who are new now during stream. So we're solving a problem in Codingame, problem Christmas Rush, where we write a bot for two-player game. And for now I implemented random moves, and also now since we are able to push row or column by one, every time when I can do it, I randomly push either column or row where I am, and thanks to this I expect to visit more cells. Okay, let me submit my program. Then many battles are run with some random opponents, and I can see, for example, here I play against someone that doesn't make moves at all, and I won. What about here? So this was won in a few turns, also 6 turns, 5 turns. So usually people submit just something that doesn't work. Here someone is stuck, and so I'm just moving randomly, and sometimes I get sometimes I get item, the quest item, or I guess in this case that player lost. Maybe he made some error, I'm not sure. But here there is a game that I lost. Why did I? My opponent doesn't move, so he shouldn't win. Maybe I myself, with my random moves, moved him towards his goal. No, he moved right now a bit. So once every few turns he moves by one, and he apparently managed to get to his goal. Let's see. Yeah. Maybe his moves weren't random. Maybe he just sees where the item is, and he tries to move in that direction. Does it make sense? So here he doesn't go to the right. Here, but no, now he would go to the up direction. So maybe not. I'm not sure. But yeah, we lost. But maybe it's because our program is encrypted, is very, very stupid. So there is something like leaderboard with rating. There is some find me. Can I find myself? I'm 8. Hooray! So as you can see, you don't need a very good algorithm to move up in this league. But so in a moment, I guess I will advance to the next league. I'm not sure how this works. Those better than the boss will be promoted to Wood 1 league at 18:05 o'clock. So I guess this guy in black is the boss, and I must be above him with points, with like rating points, in order to advance to the next league. So what about making some improvements? Maybe checking where the goal is. What's the objective? Getting to more cells? Yeah, we must get to the goal cell, and once we do that, we have the next goal cell. Have you participated in MIT Battle Code? I've spent like, I don't know, 20 hours last year. So not very much, not enough to win, of course. I didn't have that much time in January. But yeah, I tried it. And so the idea was nice, but the number of issues wasn't nice in this year at least, because they introduced, so MIT Battle Code, for those who don't know, Battle Code is similar competition that lasts for 1 month in January usually. They have big prizes. At least in last year it was only for university students, and it's an online competition, so you don't have to live in USA. And you have 1 month to implement a solution for some problem like this one, where you usually control your units and move in the grid. And you can do it in teams. You're better than the boss, you will be promoted to 1 league at 6:10 p.m. Hooray. So we advance to the next league. Let's make something smarter. You have been promoted, okay. You've made it to the next league, okay. So there are some changes now in the input. Number of items, player cards, and quests is now different. For this league, each player has 6 quests to complete. At most 1 quest is revealed. When an item is collected, it is removed from the tile and the quest is marked as completed and removed from the player's quest deck. After the turn ends, a new quest is revealed, if available. Okay, let's see if my code works for this new set of rules. I guess it should, because I don't check anything about the items. So yeah, there are a lot. So there are more items now. Don't I collect here? What happened? Maybe I have to be in that cell at the end of my round? So now this looks like my item, right? And why didn't I collect it? And I didn't collect this mask. Or maybe only one of the items in the grid is my quest item. How does it work? Also, let's make a quick survey. How did you learn about the stream? So I guess some options are code forces and maybe email from Codingame. So maybe the question is, why are you here? Looks like order is important. Yeah, I guess so. You can only complete quests, your items with a red highlighted background. Red highlighted background. You can, let's see. Okay, so right now a key is my goal. Okay, so let's try to understand. Let's try to understand where is that key. So do I read this? Also, I think when I moved to the next league, page was refreshed. Okay, so now the font is big again. What do I read that I don't use so far? Number of items, number of quests. So I read string that describes quest item name, and I read quest player ID. Let's read the description of that, and let's try to move towards that thing, I guess with BFS. Let's try to get as close to it as possible, and I think this program will crush our opponents because it will be extremely smart. So I'm going to move just as close to possible to the goal. How does it look like? Num quests, the item's name. the item's name. Okay, so let's create a struct for item. And it has some read. Vector of items. And let's read them for item in items, item read. So for problems like this, where eventually your code will become quite long, I strongly recommend using structs instead of just like arrays like you would do in competitive programming. Email. Okay, so nice to see a lot of new people, and thank you Codingame for advertising this event. Okay, string item name. String name, int row, int col, int player ID. So I guess events like this are win-win because so thanks to Codingame approval, I can stream something interesting, and also maybe I can introduce more people to the problem, and more of you will know how to approach a problem. We read now not in row call direction, call then row then player. Okay, we've read this. So now I need a goal. And what is my ID? Is my ID 0 or 1? The player's ID is always 0, opponent's 1. Makes sense. I'm not going to use constant for that because it's intuitive. Maybe it's a mistake. Maybe it's a mistake, so let me create a constant. So now when I read quests, so now one quest is open at the time, is that correct? Is collect. At most one quest is revealed. So right now the following will work. Goal if quest player ID is my ID, then let's iterate over items. If item name is this quest item name, then I found the correct item, and I write that goal is a pair item row item call. Somebody earlier suggested that it's better to make struct here, struct with row and column. Actually, I'm very much used to using pairs for coordinates, so I will go this way. It will be slightly harder for you to read in some moments, but it would be very hard for me to implement otherwise. Okay, what now? He'll let me assert that goal is not anymore pair -1 so that we indeed found a goal. Let me compile it and see if it doesn't crash, because maybe this assert will fail, so I would immediately know. Play in progress. Play my code. ×10. Also, what is very important to do later is go to the leaderboard, check our position, and check, maybe not leaderboard, last battles, and check battles that where we lost, for example, I don't know, this one, and see what our opponent does. Maybe this way we will learn some nice strategy. But for now we are in a very basic league, and so I still have a lot of ideas, and I don't need to watch games to get more ideas for strategies. You have to check player ID as well as item name. So can I have an item, and for my opponent, yeah, my opponent can have an item that has the same name. Thank you for catching that. And so if I didn't, so this is why we have these small steps, small increments in our solution. This way I can run every time, see if it makes sense. If now I will want to see if my hero moves to the goal, and maybe I would see that my hero apparently moves to my opponent's goal sometimes. So then I would catch it. Okay, if item name and item player is my ID, then this. Okay, so what now? Well, some idea is to check. Let's create a function distance that gets two cells and just returns Manhattan distance between. Manhattan means just the sum of column distance and row distance. A first minus B first, so the difference of rows plus the difference of columns. So this way I will check if I'm close to the goal. So if I can go in this direction, but also so R2 is me row plus delta row of dir, C2 is me column plus delta column of dir, and now if I can go in this direction and distance between the goal and new cell would be smaller than the current distance, distance of goal and my current cell, so me row me col, only then I move. Let's try this. You have to check that. So this is my goal. For some time we cancelled each other's moves, and I made a mistake. What happened? Assert fail base, blah, 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 line 127. Assert goal is different than this. So is it possible that I don't have a goal? Let's decrease the speed. So actually it was just after I got some goal. Okay, my goal was outside the grid, as you can see here. So if goal is -1, we shouldn't do this, and instead then we will move randomly maybe. So if maybe if I can't go in that direction anyway, continue. And now if either goal is -1, or the distance decreases, then I move. You have to check player ID. The goal tile is in your hand, not on the grid. Yeah, thank you. Yeah, unfortunately, as you can see when I open chat, also I can do this. There is some delay, like 15 seconds when I stream. You can just pass. I can, but I actually I prefer to move randomly. Why not? If I move randomly just through the grid, I think I have better chances to go get something, generally. Of course, maybe if now I want to get to some particular place. Okay, something was wrong a moment ago. Because I didn't push a column where I am right now. Why is that? Maybe something was wrong. Can't move at all, that's okay. Both players try to push the same end, that's okay. Passed. So why did I here push this column? Maybe. Ideas. Goal can be -2 if the opponent has it. Interesting. Does it happen here? It doesn't, but it's worth noting. Okay, thank you. Rows are pushed before columns. Your opponent pushed a row first. Oh, okay. Let's see. Okay, my opponent pushed me, and then I pushed the column. Makes sense. Okay, thank you, Christopher, for noticing. Okay, so it's not my mistake. What was a mistake pointed by Okilol and 20 was that goal can be -2. So let's here say that goal first is smaller than 0. And once it's done, I will submit my program so that it would run against more programs. Better speed. I think that so this game is especially important for me because I lost, and it was like 6-0, but just the opponent, I think, does smart moves. Also with pushes he gets closer to, I think he tries to get his goal towards him. And so also my next step will be to make smarter pushes, not just random ones. But still, let me submit. And let's see what happens. I guess this code should be enough to move to the next league. I have place 101. Let's see if that changes. The games are still going, so my place should adjust every few seconds, maybe tens of seconds. 83. Okay. Also, we see here like a small circle that says what part of battles are already done. When this circle is filled, then my position is like perfectly adjusted because I played with like enough battles. Okay, so let it run. So now I don't want to push randomly. if maybe this, if my position, if my row is smaller than row of my goal, then I want to, let's say, push myself down, or maybe push goal up. Okay, so maybe if goal first is smaller than 0, so it's outside the grid, then I do a random push. Okay, otherwise, if my row is smaller than row of goal, then I want to, let's say, push myself down. So cout push my column. Yeah, my column. This is no. So yeah, I'm pushing my column down. And direction is down. Else, if I'm above, maybe I should have make this like more automatic with some for loops, but it doesn't look terrible this way, so whatever. Here I want to push a column, and its coordinate is my row. Does it make sense? If my column is smaller than goal column, so if I'm on the left, then yeah, okay, makes sense. Maybe I can write this way: to the right. And finally, if I'm to the right, push me to the left, and otherwise I'm in the same, let's say, assert false. Let's say we can't get here. It would mean that I'm exactly at the spot of goal, what is possible, I guess, if I got to this exact cell. So here I will write if this. Let's see what happens now. Or me make pair me row and call is equal to goal. I'm not sure what happens. It depends on the order, maybe. I'm not sure if something bad can happen now. If I reach the goal in the middle of my turn, so after move turns, okay, it isn't an issue, I guess, because either it's a turn for moving where I can reach the goal, or it's turn for a single push. So I think this is impossible, because if I start now, so if I start a turn, I can't be on the same cell as a goal, right? So this is impossible. I must be on the left or right or so. Also here we see some infinite loop where we both try to push the same thing. And it's bad. Let's say that I never want to get a tie like this, especially if he got one goal at the very beginning. So let's fix that very soon. So if you are stuck, do something random. Let's see the leaderboard. Place 36. Could be better. Okay, so let me play code again. This time maybe not. I want to see more interesting game, not just something that is now running forever. Play my code. What happens? Okay, I move randomly because my goal is outside the grid. And now there is a loop. Okay, so let me fix this now. Okay, I think it will happen often that I will try to I will push my goal outside the grid, and it seems like a very bad thing to do. So if I'm like here in the same row as my goal, then it doesn't make any sense for me to push myself towards a goal. So here let me write, or my row is the same as goal row, or column is the same. What about this? Of course, I could do something much smarter given enough time. Just first, it's better to write something that would get me out of this how do I call it? Like infinite loop. Where is my goal? Oh, it's here. And now we are stuck. Okay, I will submit this code again. Place 47. Let's see a battle that I lost. So I want to get to bottom left corner. Now it's quite close to me. And yeah, it's bad if I push it outside, and now we are stuck for a moment. Okay, looks reasonable for my algorithm. Okay, let's do some improvements. So in my to-do there is, if you're stuck, do something random. I will do that very soon, because it's quite easy. You can push your goal outside and then push it next to you to acquire it. Yeah, but it's much more complicated thing to do. Like, especially for starting, it's better not to rely on some very particular ideas that we can use sometimes, just to work on general code. For example, now I can more or less move through the grid, but in a moment I'm going to do it in a smarter way. But yeah, this is one of things for the future. If you're 1-0, just push one up, push your hero to bottom, and tie with the item. Yeah, I understand that there will be a lot of possible hacks, but I think that eventually, eventually my code won't have many ifs like this. Instead, we'll use something like min-max tree, where I consider every possible move I can make, every possible move that my opponent can make, and I will try to consider every few possible next moves and check what is the best scenario. So this is how you usually solve two-player problems, where the number of possible moves isn't very big. And then what we need is the implementation of the functions. For example, what happens if we push this row? And it doesn't really matter, like the ifs in this program doesn't matter much, because our program will consider everything. So it's more about moving through the grid, stuff like that. Okay, what I'm going to do now is modify the distance thing. I want to check if I'm close to the goal by running BFS. So there will be BFS here. So I start with cell A, and I want to see within what distance I can get to some other cells. What I'm talking about is where can we see something like this. I want to see a place where we can get to some cell, but not really by moving just in that direction. We can for a moment go in some other direction to go around, and then we can get to the cell. Let's say this will be already considered, so visited cells. Visited of A is already true. We iterate over cells. Row is call I first, call is second. So this is like call is a queue. Maybe I will call it a queue. Now in every direction, if can go from row call in this direction, then R2 is row plus delta row of dir, delta call of dir. If inside, so inside must be true. If not visited of R2 C2, then call push back and place backward here to C2. We need distance, so here, of course, this is not very interesting for this particular problem because it's just a known algorithm to find distances from one cell to all other cells in the graph, from a vertex to other vertices in a graph. So here I will write, so at the end I want to say return distance of B first, B second. And actually I want to say that, so right now it finds distance within one connected component, so where I can get right now. And I don't really need that. I want to say that within one component I can get to whatever cell I want. What I can do. Let me write a different function. Let me write a function that returns the set of cells that are achievable from this cell, that are connected. This will be connected component with this cell. For example, here for this cell, I would want to find a list of all the cells that you can get to from the cell. Okay, so let's actually create a set here, or maybe a vector. Let's call this vector a list, or maybe not, vec. Let's add first this cell A, And now for every other one, we do what we did here. Now, if not visited of R2C2, then vec in place back. And here it was just a pushback. In place back R2C2. Return back. Okay, I also need visited. Let's see if it compiles. So this should return as a set of cells that I can get to. Q was not declared in this. Okay, we can call it Q. Okay, it compiled, but something was wrong. Okay, but because distance is now, maybe it has some bugs. Let me get back to the previous version, where is just Manhattan distance. Now everything should work correctly. It's just about using this component thing. What I want to do is from my cell to check with this function what are all the cells that I can get to in like this turn, and go to a cell that has smallest distance to the goal that I want to get to, instead of just going in one direction. Okay, so what I will need. Also, when I find this best cell, I want to know how to get to that cell. So we must add something to this BFS. We must remember here where we say that from row call we get to R2C2. So here also visited we need for sure. And here visited of A is also true. So visited is true. And what I would add is for every cell I want to know from which cell I got here, and this way I will be able to create a path to the goal. Previous cell. Okay, so here I write previous cell of R2C2 is row call, and let's give the goal to this function. Let's find the best cell in this connected component. Maybe it's A, but maybe for every cell in Q. So these are cells that are we can get to this cell in this turn. Let's move the distance function above so we could use it. And for every cell, if distance of this cell to the goal is smaller than distance from best to goal, then best is this cell. So now we know that among cells that we can get to, best is the best cell, so closest to the goal. And now we want to find a path that leads there. So let's say that this will, maybe instead of returning, let it move. Let's say that this function will print the move. what do we do? Let's find the path to the cell we want to get to. Now while best, so now best is the cell we want to get to. Well, best is different than the starting cell. Path pushback best. Best becomes previous cell of best first, best second. Also at the end path pushback A, the starting cell, and reverse. So far from the end we gathered the path to the cell best, and now we reversed, so we have it from the beginning. And what will be the moves? Well, for every pair of neighbors, we move from path of I to path of I plus 1. This should be two adjacent cells. And for int dir is 0 up to 4 plus dir. So we move, let's say, from row and call. R2 would be row plus delta dir of delta row of dir. C2 is the same for column. If row 2 is equal to path of I plus 1, we found the direction. So let's say that we'll here see out dir name of dir. Here new line, here see out move. Also if size of path is 1, so we don't want to get anywhere, then we want to skip, so pass and return from the function, otherwise we move. So I hope that this function will either stay in place if it's optimal, or go within this within its connected component, go to a cell that is closest to the goal. So let's run this component. It should get the current cell and go. If goal first is greater equal 0, so we are inside the grid, then we do component, takes our coordinates, me row, me call, and the goal. Otherwise, let's do what we did so far. Okay. How long do you plan to stream this? Time zone problems. I think I will finish the implementation in a moment, so I'm not going to implement anything more today. And I will spend some more time talking about possible ideas, solutions that I have. And so that will be it. So around maybe, let's say, 15 minutes. Okay, compilation errors. Vector of vector parents. I wanted to here create the vector of vector. So this is now two-dimensional arrays. What else? Expected something. Path I plus 1. Where is it? Maybe here I have to write make path. Let's see. Okay, it compiled. Do we now push randomly, or how do we do it? Maybe it's better to push randomly, because otherwise we often can make the goal further away from us. So actually let's get back to pushing randomly. So if true, so I always push automatically. I'm just not sure if this is good for me now, because I see some situations where I'm close to my goal, but I anyway push myself and the goal in the same direction. Let's see. Makes some sense. If true, okay, let's make it even more random. Let's sometimes push maybe, so I'm going to do that later. To do, sometimes push the item, so the goal, unless it's outside the grid. Just to make it more random, because I see that often we are stuck. And I guess this will be like, I will not code anything more today. Also because it's bad if I show too advanced code, right? Because this is still a competition where you should try to get a good program yourself. So this is some introduction. I will tell you some more ideas that I have, my thoughts about problems like this, what you can use, what you can do. So let some games run. So I think the cool approach to problem like this is to think what we can do. For example, to think that if our opponent is close to his goal, then we can move him further away from the goal. This sounds cool. Like, this is what you would sometimes do. Like, you can think what you would do as a human while playing this game. And not only we would push ourselves towards our goal, or make some path for us towards the goal, but also sometimes we could spoil the path for our opponent. So either move him away, or his goal away, or he'll go outside the grid, maybe for a moment, and then later we decide where his goal should be. So and then it sounds like something very important. So if I leave my goal at the edge of the grid, then my opponent in his turn can move it outside the grid, so it will not exist for a moment, and then he decides where it should go, because it's outside the grid, and he decides what is his next push. Sounds very dangerous. Actually sounds like this, well, this game is quite stupid because of it, but the statement suggested that in harder leagues there are a lot of, well, quests, a lot of items we want to get, so then it won't be that important. So maybe it doesn't make much sense to implement that. So this is an example of a cool idea that you can have while you analyze the problem. You think what you would do as a player, indeed, in the game. And but generally, if it's possible, the winning solutions look like this min-max tree. So this is also how you would implement a bot for chess and many other games. If there is some quite small number of possible moves, for example here, usually what is the possible number of moves we have in one turn? Well, if we can push in like there are 7 sides. On every side there are 7 possible rows or columns, and there are 4 sides, so 28 possible moves. And when we move, when it's turned for moving, usually our component has size like 10 or something. So instead of thinking how exactly to move to get somewhere, we just think to which cell in our component we want to get to. For example, right now, I can either finish my turn here or in the next cell, So there are only 3 possibilities. Oh, also we can wrap around, right? So one more thing I must implement for sure. Go like wrap around. From this cell we can get here. Or we can't. Well, for sure we can push ourselves. But if there are like 10 or 30 possible moves every turn, you can consider all of them for you, this turn, for your opponent, and consider like few possible turns, all possible moves, and choose that first move that leads to the best scenario. Well, you assume that your opponent moves maybe optimally or kind of good, and you see if he behaves optimally, what is the best thing you can do against that. So like in chess, not only consider if you can beat something in this turn, but you consider what are possible scenarios 2 turns away or 3 turns away. Of if you are better, or in this case, if your program is better, you can go deeper. And the optimization of that later is that you don't have to consider all the scenarios. You can cut down some of them. So you need to create some function to evaluate the grid to see for this grid, do you like this state of grid or not? Do you want to get this state of grid? So maybe the function will be your distance to the goal or something like this. And also a very important thing is the number of points already. If you can do such two moves that they will lead to a point, then do it. So you consider some first moves, some second moves, and then those scenarios where you're already losing, you can cut down. Let's say you don't want to get there anyway. So instead of complexity 30 power the number of turns you're considering, you will get something less than that. So some problems are like this. I think this is an example of such a problem, that there is only so few possibilities every turn that this is a viable option and this will be the winning strategy, just written in some nice way, very fast and with good evaluation function. But I think that much cooler thing to do is the other ideas, to just think what we can do, so some greedy, stupid algorithm. Also, I'm first in this this leaderboard, right? Or I'm not? Oh, I have 0. I guess a moment ago I was first. So I will move to the next league, and also there will be some more rules. What's the best algorithmic complexity one can go for that problem? The complexity isn't that important. It's more about the running time, so constant factor matters. Just you can't do a lot of computation, right? So here I think that if we do strategy like this that only considers some move, for example, I want to push myself towards the goal, then anything reasonable will be okay. So the grid is kind of small, 7 square is 39, and we can have, like, I don't know the time limit, but likely we can have the size of grid power 3, maybe. And but then for the min-max tree, you will try to squeeze everything as much as possible, because every improvement of speed will result in the possibility to consider more scenarios. So just like in chess, so you can implement the chess bot for chess such that you consider your first move possible, then every move of your opponent, and so on. But if you see that this first move of yours leads to your opponent beating your pawn or getting your queen, then it doesn't make sense, likely. So it's hard to say in terms of complexity, because we'll cut some states. So I think in competitive programming, something like this is called a backtrack. So well, also what we have here maybe is what you might want to read about is alpha beta pruning. That is like the art of cutting down something, and we don't consider that in terms of like there is no complexity in that. You just cut down some states, but everything is exponential there, like something like the number of possible moves power the number of turns you're considering times polynomial of the size of the grid, but it doesn't matter much. Will there be any more of your streams for this game in the remaining 4 days after you develop more advanced bots? Top players won't get affected anyway. I think they would be affected. Have you watched Records' stream for League of Legends? Midstream that he showed was a very useful idea to get data to debug locally. I haven't watched him. I'm not aware of him. Not League of Legends. It was for Legends of Code and Magic. I haven't. So I understand that there was a stream for similar coding game problem. So yeah, I didn't cover anything around the technicality of all of this. So I said in the statement, they said that you can see the game source code here and you can do something locally. Also, we can, I guess, you can do some more printing to error output to get some data. Just as long as you make small improvements, I like just changing something and here running again and seeing the visualization that shows whether my program behaves optimally. If you want to, let's say, go pro, you need to do things locally. You need to create some program, and if you want to really know its value, you can, for example, if you want to check some parameters, because usually in those evaluation functions, it isn't just about some ifs. It's about evaluating the quality of step or the grid. So there are some parameters like how much we care about the distance to the goal, how much we care about the number of points, how much we care about our distance to our opponent. Maybe it matters. So all of these are some parameters that you can adjust, and it's easier to be done automatically in your own machine. Just checking many possible parameters and running the programs against each other. So I'm not very experienced with Codingame, so I couldn't tell you much about how to do well, especially Codingame. Things that I covered so far are generally for problems for like 2-player bot games. So also MIT Battlecode is similar, and there were some on-site competitions in Poland, like Marathon 24, where you had 24 hours to write a bot to a game, and game usually was played by 30 players at the same time on a big grid. It was cool, but I think all of those competitions are finished and there is nothing like this anymore. Will there be any more of your streams for this game? I think it's quite late for that, because it's already close to the end of the competition. I consider that, but also I don't have that much time this week. So maybe I will be back in the next Codingame competition. And also, if I show something more advanced, this starts affecting the top of the leaderboard. So it's good to teach basics. It's good to show my ideas, like not very complicated ideas. For example, it would be, I think, quite bad to show the code for to stream coding the min-max tree if it indeed leads to the top 100, because everybody could copy that and it would affect the top. So, and also the organizers told me that you can't go too well, right? So I didn't try to go bad in these 2 hours. In 2 hours I did what I could, while also explaining. So of course, without explaining everything while I go, I would be a bit faster. But yeah, in a moment I will advance, I guess, to the next league. So I want to the bronze. So right now there is wood, bronze, silver, and at the 12th of December, the gold league will open. So it's today. Okay, so today there is a new leak with some new conditions, I guess, new rules. I want to just see what is the next leak. So what is new in the bronze? I guess that when I'm done testing, so this circle is almost full, I will advance to the next leak. So I'm continue. I will advance in a moment, and I will also finish the stream in a moment. Yeah, if you like the stream, consider subscribing to the channel. I usually stream competitive programming. Recently I did a couple of lectures about quite hard algorithmic topics, and also I want to go back to problem solving during a stream. So if you're interested in either competitive programming, or you like algorithms, or you want to prepare for the coding interview, stick around, subscribe to the channel. Also, if you like the video, I will highly appreciate that, if you indeed liked it. And yeah, what else? What do we have here for this league? Each player has 12 quests to complete. At most 3 quests are revealed. A player can complete multiple quests in one turn. Okay, so just the bigger number of quests. So my code wouldn't work so well because now I only find one of them, and here actually I should store all the goals and try to go to the closest one maybe. And yeah, if you have suggestions for my streams, in the description you will find the link to Facebook group and the Discord channel. You can reach me there. I do read the suggestions because there are only a few of them, so I do read all the comments and so on. I hope we'll see again, and my next stream will be in the next week, I think around Tuesday, and it will be algorithmic problem solving. But also, if you're interested, you can go check out Algorithms Live, where this weekend, I think on Saturday or Sunday, I don't remember, there will be an episode with me. So we will talk about some particular problem, one of my own problems from Codeforces rounds, from the recent Russian Wiki Cup. And also we'll talk a little bit about the education in competitive programming, about my streams, stuff like that. So also go check out the channel, because he has some interesting lectures and also interviews with people like Scott Wu or Lewin. And yeah, so you can see me there on, I'm not sure if Saturday or Sunday, but for sure I will announce it in the Facebook group and Discord. So thank you all for watching. I hope you liked it, and see you next time. Bye bye.